Hi, I'm Farai and this is my code lab. Today I'm going to start Ctci again. Since it's a new year, I just thought we'll start doing things afresh and going through the book, and I hope to get through all of it. I don't know, it might take the year or half the year. We'll just see. I might need to go back to some questions which I can get or like learn on new techniques and use them, but yeah. Let's get started with 1.1 in the chapter Arrays and Strings, and the question is unique. Question is to implement an algorithm to determine if a string has all the unique characters. What if you can't choose additional data structures? So, oh no. That's not too much, so this should be pretty quick since done this over again, although once it was asked in the interview, I had all these complicated thoughts and it was just like, whew. So, I think I'm just going to keep a dictionary. So, function is unique. And I'm going to keep a dictionary of let's just call it scene dictionary. I think some places call it a map. I don't know, it depends. So X, yeah, let's not call it X, let's call it R. R reminds me of the joke. What is a pirate's favorite letter? Programming language, I mean. And it's like, you're tempted to think it's R, but 'tis the C they love. Anyway, let's start. So, for I of, I'm just going to use I of R, if C in R, then C in R plus equal 1. Else, it's just going to be C in R is equal to 1. Wait, yeah. Is unique. Oh, shoot. It's not an array, it's a string. So, let's get rid of most of this. Sorry, I've just been feeling kinda weird. str. So, for I equals 0, I is less than str dot length, then I plus plus, if C in str I hey, sorry, let's fix that. So if that string is in, then turn false, else scene str I is equal to true. And afterwards we return true. Since we've gone through the loop, so let's do A, B, C, D. And then we go. So for I is 0, so that's A. Is A in there? Nope. So like we have our dictionary with A. True. B. True. C. True. D is true. Then if we put an A, and then A is in there, so it will return false. So I would say this works. As for the part about how to do it without additional data structures, I think this is bit manipulation. Which I really need to look up. So, not and, nor. Because you have a series. Not and? Yeah, because what? 1 and 1, that would be 0. So that means not and. So, like I said, I'll look into this later. So let's check the answer. We didn't even need the hints. That took 10 minutes. Okay, is unique. Yeah, that's practically what we did. Yeah, that's... And by using a bit vector, we will assume the below code that the string uses lowercase letters A through Z. That allows us to use just a single int. So, however, we can do the following. Compare every character of a string wow, I'm really out of whack, but let's go on to question number 2 now, which is check permutation. Write a method to check if one string is a permutation of the other. So, what do we know about permutations? Well, they have the same letters, right? Like, fudge. What word is a permutation? Yeah, so they have the same letters, right? That's what we know. I'm trying to think of one. Oh, yeah. Doom, same letters and same number. of letters and mood. Yep, that's a permutation. Or you can do ood or do or modo or domo or demo or yeah, that's as many permutations as I can come up with doom. So I think for this, the way I'll approach it is I will just let's do function is mutation and then A, B, right? So the idea is to sort them out. So if A dot length is not equal to B dot length, then it's false. So now we need to like sort the string in some way. So A R A is A dot split dot sort R B is equal B dot split dot sort, then return R. Actually, no, this won't work. Because then you have to put it into a string again, which, yeah, so I won't commit to this. Rather, I'll use the approach from the previous question, the is unique, and I'll do that. So, yeah, so let's call it scene is equal to so what I'm thinking, I'm making the array and then counting their frequencies, then subtracting the frequencies and seeing if they're all 0. So we're just going to do a frequency thing for I0 as less than A dot length, then A plus I plus plus, then the frequency. So if scene whoa, wait. I realized there was a bug in the previous thing. Sorry. I did not see it. Fine hell. Okay, let's get rid of that. Let's get rid of that. Yeah. Okay, so if it's seen, then so seen A, I, right? Then seen A, I plus equal 1. Wait, I think I fricked up the previous one. No, I didn't. Wow, I'm really out of it, eh? This one, else seen A seen A I is equal to 1. Yeah, so that's one loop. Then the second loop is to like take away the frequencies. So for I, let's call it j equals 0. J is less than length, then j plus, right? Then if str b j then str the fudge. Why is it called? It's seen. Seen b j is minus equal 1. Else, that means the letter isn't there, so you just return wait, no, this is not the end of it. Let's if seen b j is equal to 0, right? Then you return false. Else seen b j minus equal 1, then else return false. And after all of this, we can just return true, shall we? So, to walk you through what I'm doing, it's that we're checking if the lengths are the same. If not, then they can't be permutations of each other. So we make a frequency table of A, right, as you can see. Yeah. Then for each character in B, like if it's in there, right, and then if it's 0, that means they're unbalanced and we return false. Is it possible to have less? No, you can't. By definition, you can't. I mean, okay, like, look here, if it was mood and moo, you'd be taking away 3 of the characters. But if it's wow, then that's a new character. So I would consider this condition impossible. Like, you can't have, like, the thing with, like, 2 characters left and no. So I'm committing this. 1.2 permutation. Okay, like many questions, we should confirm, we should understand that permutations are case sensitive. That is God a permutation of dog? And do we consider white space? Although in our thing it just doesn't matter, a character is a character. Observe first that the strings of different lengths can't permutate to each other. There's a different way to solve one, both of which use this optimization. One is to sort the string, which is what we started with. That would be n squared. What would ours be? It's 2 n loops, but then the dictionary is n plus n space. And this one's not optimal, it's preferable, it's clean and easy to understand. Solution 2 is 2 words of the same kind to implement. We iterate through, counting how many times each character appears. And afterwards, we compare the 2 arrays. So yeah, this one is just frequency table. Note the assumption on line 6. That means they're using ASCII, so yeah, I think I'm pretty much doing this, more or less. So yeah, I would consider this a pass. Now 1.3 is URLify. No, why am I looking at the solution before I've done the question? We want a method to replace all spaces in a string with %20, the encoded one. You may assume that a string has sufficient space at the end to hold additional characters and that you're given the true length of a string. Note that in Java, use a character array so that you can perform this operation in place. Okay. Oh yeah, so we get the true length. Really not, but you just been doing. Wish this one was kind of tricky, but you have all the space you need. You could just make another string, you know. but this is in place. So I'm going to assume that it's literally an array of characters, not really a character array. So function URLify, and our text. Then it's text and its length, the actual length. So you'll have like 2 pointers. So I'm thinking Mr. John, right? So you have 1 pointer here and 1 pointer there. So my idea is move that over here, right? And we have Mr. John. Oh, there's enough space at the end for it, so. Oh shoot, let's look at our example. So we got 1, 2 spaces, so that should be 4. Yeah, so this will work. Well, N, so you move in, then N, then you go here, then it's Mr. John, but it doesn't matter. Go to the end, Mr. John, then J to the H, Mr. John. What we're doing over here, since it's a space, then that's a 0. Then you put your 2, and then you put your %. And then you decrement the pointer by 2. And then once they equal, you decrement your pointer by 2. So then you end up just doing that. So you can just terminate it early. So 2 end is equal to text length minus 1, and then the len we're in the A end. So this is the true, this, let's call that end, is just len minus 1. So this is 1, 2, 3, 4, 5, 6, 7. So len is equal to 7, but then the text length is equal to 9, right? So you just minus 1, so you'll get like 8 and 6. That'll be 0, 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Then while shoot, these should be better than a while t end is not equal to end, right? If, wait, no, that's not possible. It wouldn't run. If my condition's right, like where you just terminated this cross point. So, if t end is equal to a space, then my goodness, I am so out of this. I apologize. Over and over. Text dot. If, all right. Text end end minus 1 is equal to 0. Text end minus 2 is equal to 2. Text end minus, shoot, not text end minus 1 minus 2 is %. Right, and then how do you bump down? So A, B, so here, then let's do, I need to cross check here. So A, B, C, so yeah, so you see goes there, so you just do n minus 1, so that means C da C da B da A, C 0 to %, and go here, and then you go 1, 2, see, so okay, so you start here, then minus 1, and then minus 2. It's here. So then, yeah, we just subtract 2 from end, and minus 2 equal. Minus equal to, else test end is equal to test t, and Then we just do end minus minus, and then t end minus minus. So before I can like commit this solution, I actually need to test it out. So let's get our ABC. So our A blank, B blank, C blank blank. And that means that 1, 2, 3, 4, 5. That means actual length is 5. So that means t end is 1, 2, 7 is 7. So this means it's 6, and then end. No. It's 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, it's 9. Sorry, let's just clear this out a bit. A blank, B blank, C blank, 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 blank. Okay, and then that's 1, 2, 3, 4, 5. That's 5. So the end is 1, 2, 3, 4, 5. So it's equal to 4. Then end is equal to 1, 2, 3, 4, 5, 9. And it's 1, so that's 8. So we start with and let's just call these T and E. Let's move this down here. T and E. So 4 and 8. So right, so that means 8 is here and 4 is there. So we move it over, so that's C, 1, 2, 3, C, da, B, da, A. So we decrement both of them, so we get 3 and 7. So 3 here is a space, so that'll be C, that'll be 0 to %. Right? So we subtract 2, so that's 5, minus 1, that's 4, so that's 2 and 4. And then C, yeah. Blank, B blank, A. So 2 is here and 4 is there, so you could just switch them over. 0 to %. C, no, it's B. Blank, B blank, A. So you decrement 1, so we get 1. And 3. And 1 and 3, so that will be 0 to %, B % to 0C. Then that's minus 2, so it would be 1. Then minus 1, so 0, 0, so that's A % 20, B % 20, C. And yeah, this solution works. We're going to check this answer and I will wrap it up here. So our solutions. Your LFI. A common solution to manipulation problems is to edit the strings from the end and working backwards, which we did. This is useful because we have an extra buffer at the end, which allows us to change characters without worrying about auto-overwriting. That's how we solve it. We use a 2-scan. The first, we count the number of spaces by tripling this number, we can compute how many extra characters we will have in the final string. Okay, but you may assume the string has sufficient space at the end to hold the additional characters. So why do we need to count the spaces? So space count plus by tripling this number, we can compute how many extra characters will be in the final string. In the second pass, which is done in reverse, we actually edit the string. When we see a space, we replace it with %20. Then we copy the original character. So space count, index I0. So you're looping through. Okay, honestly, I don't know why it just cuts out like that. So, okay, we're back to it. So you count how many spaces, you triple the number to see how much extra space. In the second pass, we only edit the string, so we know the spaces. So this one's looping back. The index is right at the end because that's the extra space we had. But yeah, so I think we did the same thing. It's just the extra space won't actually be a space. I think the way I messed up was I represented the space as a space rather than null, which is what it actually is. So yeah, I think we'll stop here for today. It's been a pretty productive session, although I've done this many times. Things will only get harder from here. So yeah, thanks for watching, and I'll see you next time.